Okay, good morning. I think it would be better if I give you some problems and wait for you to solve and then discuss it here on the board. When you are tired, I can stop and you can start working on your own, okay? Okay, so the first problem I want to write here on the board and wait for you is this. I want you to simplify this expression as much as possible, okay? So 81 to the power of logarithm of a square root of 5 in base to the base 9, and then I have plus logarithm the fourth root of 2 to the base 3. So I think these kind of problems will help you to send the properties of logarithms to your memory, which is probably useful. So I want you to simplify this expression as much as possible. 81 is the base, and the whole expression you see here is the power, is the exponent of 81. I will wait for you, okay? When you have your answer, you can read it. I can see the final answer here. Yes?
Is the answer 10?
Yes. I will give a little bit more time to others as well. Okay, anyone else? No other answers? Yes?
Also 10.
10. Okay, so let me solve this problem. Might be you need some refresher for your memory. So how do you think about the problem? Because the only method that we can solve these kinds of problems that logarithm appears in the exponent is this formula, yes? So somehow I hope that this should be clear for you that this formula will be somehow relevant to this problem. Because if you check the list of the formulas, this is the only one that logarithm appears in the exponent. Yes? So this is the logical way of thinking. And then you need, in order to be able to use the formula, you shouldn't have any number here, but these two numbers should be the same. Of course, you see that these numbers are not the same, but you immediately, hopefully, realize a connection between 81, 9, and 3, yes? All of them are somehow related to powers of 3. This is the logical way of thinking that I'm just talking. Of course, I can solve the problem for you and you can understand it. But the point is that how to understand, how to think about the problem, yes? So, the first thing is that let us get rid of this. Is there any way that we can simplify these things? For example, let us concentrate in here first. Okay, so I have log 9. So I have this one. So do you have any suggestion here for me how to proceed? So you see, this is not hard. If the problem looks hard, you have to solve every bit of it. Yes? So every bit is not that hard. So can you tell me, for example, you can forget about what is happening here, just concentrate on here. And if that's hard for you, you can concentrate only on this bit. Yes? Yes?
First of all, we can write 5, square root of 5 as a 5 over...
Yeah, so we had this experience before. So let us just do that. So I would write this, instead of 5, I would write 5 to the power of 1/2. But do you have any idea? Because it's good to do things in parallel.
Yes. 3.
It is better to write it as 3 to the power 2, yes? Why? Because I want to keep 3. Because we have a formula for what happens if I have a power here as well. And I will do the same thing here. So you see, it's not hard. I don't know how do you think, but you need to do it step by step. So I don't know how many of you consider this hard. Everyone knows that this can be written in that, and you have enough experience and you have seen very problems of this type that I have to get rid of search signs and write them in an exponent form. No? Okay, and then you learned yesterday that what happens if I have an exponent here, and what happens if I have an exponent here. So I will use it, okay? So what happens here? Is it good or not? We have to see. Then what happens in 1 over 2 goes there. But what happens for these two?
The reciprocal.
The reciprocal becomes also 1 over 2. So let us just do it step by step. 1 over 2 goes to the back. This 2 becomes the inverse, the reciprocal of 2 becomes 1 over 2. It goes back to this one again. And then I have log 5 is left, base 3 is left. And then of course the next one, 1 over 4 will go down. And then I have log of 2 to the base 3. Yes? And then I have 1 over 2 times 1 over 2, which can be simply written as 1 over 4. Then I have log of 5 to the base 3 plus 1 over 4 log 2 to the base 3. Okay, so, but I haven't lost my logic, yes? My logic is to make it one logarithm with the same base. And I know that, hopefully, 81 is what? 3 to power? 4. So far so good, that's good. At least I have a connection with 3 here. And I have now my basis to be 3 as well. So what we should do, what do you think I should do now?
Put it back.
Move the 1/4 down to the base, so they become 3 to the power 4.
No, yeah, so it becomes, yeah, that's also good, by the way. I haven't thought about that. But that's actually better. Yes, let us follow yours. Yes, I was thinking I wanted to factor 1 over 4 out, but now I realize it is even better. I move this back in here, yes? So, thank you. So what I do, I want you to understand what's happening. So I do the reciprocal, it becomes 4, and move it back here. Yes? Yeah. And then what you do there, it becomes 2 and 3 to the power of 4 here. So it's even much nicer. Thank you. So this becomes logarithm of 5 to the base what? 81. And then this becomes logarithm of 2 in base 81. But yesterday we learned about what can I do with these two logarithms. What can I do? Yes?
You can turn them into logarithm 5 times 2, or what base it is.
5 times 2 in the same base, yes? And 5 times 2, everyone knows that it is 10. Yes? So I was able, actually, to simplify this power, this exponent, to a large extent. That's better. And then I am done. Because then I can move and say question mark is equal to 81 is already there. And what I calculated for the power is this one. So it becomes logarithm of 1081. But now, can I use this formula? Yes, everything is in order. So what's the answer? Yes? So I don't know which way you did it, but I think it was a nice trick that Melker mentioned.
Okay, Baba, I have
Yes.
a question. So if you have same base and subtract or addition sign, can you multiply the 5 by 2?
Yes, because I told you that when you have logarithm of x times ya, you can write it as logarithm xa
Yeah.
plus.
I forgot.
Okay, I told you that whenever you learn equality, you need to learn how to go back and forth. Sometimes this is given, you have to write this. Sometimes this is given, you need to write that. Yes, that's possible. Any questions? So I would consider it a extremely hard problem compared to Math 2C problem, but it is doable. It's not that hard. Yeah, I don't think you have questions like this in the book. So even A-level questions are lower than this. But I mean that if you learn things, it's coming automatically. Yes?
Yesterday we had a third in the base, and then we could write, let's say, log
Log what?
log of square root of log of b
B.
in the square root of a,
Yes?
and then we could change it into log of b squared
Yes? Yeah.
in
Base
base
A.
a. And can you do the same things but the other way around? Because now we
So
have
here-
a third in the
Yes, we can. So for example, if you have this one, let us see, I don't know, I have to answer it. So you mean something like this.
Yes.
So then what you do, yes, you can do that. So this
Because-
becomes b to the power of 1/2 a. You move this to the back. It becomes 1/2 log of b in a's, but your intention is to move it here.
Mhm.
Then you have to do the reciprocal. This becomes ba squared.
Because I skipped the middle steps and just moved from.
Yeah. I mean,
And
exactly. But when you skip the middle
Yes.
terms and did the same thing, it means that you know about both of them.
Yes.
You just write it in a compact form.
Yes.
If you understand what's going on, that's even better.
Okay.
Yes. So you have another proposal for this?
No, we came to the same answer, but it was just.
So you might
Short,
skip some.
short.
Yeah, you can do that. But I want you to understand, if someone asks you why this is correct, you should be able to explain as I did.
Okay.
But if you really know what is going on, you can just jump from here to there. Yes. Okay, so that was one starting question. So now let me ask you some more questions. Okay. We want to calculate this. Logarithm of 2 in base 50 plus logarithm of 3 over 2 in base 50 plus logarithm of 4 over 3 base 50 plus, and then you continue, plus logarithm of 50 over 49 base 50. Let's wait. Okay, I give you time to find this. So by the way, if you want, this is 2 over 1 if you want. So every time I add a number in the numerator and I add one number, if you want to, I can write this 2 over 1 as well, yes. So of course 2 over 1 is 1, but the next one is 3 over 2, the next one is 4 over 3, and then you continue until you reach to 50 over 49. And you want to calculate the answer. Just wait a bit. Okay, Oscar, what is your answer? You said that. Yeah, what is your answer?
1.
Yeah. What? So is that understandable? Everyone understands. So it seems a hard problem, but that's extremely simple. Yes. So what we are supposed to do? Anyone else? Can you guide me through it? Because you see, I have a bunch of logarithms added together, but the base is the same. So what can I do if I want to? I can write it as 1 log with the same base. But what I have to do, instead of adding them, I have to multiply them. It continues until the very last. But can you tell me what is the previous one as well? That's always instructive in these kinds of problems. What is the previous fraction? 49 over 48. I hope that you agree what is happening. If I write something like this. Yes? Now the interesting thing is that the fractions are designed in a way that they cancel one by one, yes? So the numerator of that one will be cancelled with the denominator of this one. The numerator of that one will be cancelled by the denominator of this one. And the numerator of this one will be cancelled by the denominator coming next. And this process will continue. And then when you reach here, this one is cancelled with that one. This one is cancelled with the previous one. And what is left? Only this one single one left here and 50 left there. So it means that this, what's the answer? This becomes log of the same, in the same base. But what is the number left for me of all this product? Is 50. Yes? And then I have log of 50 in its own base, and this is 1. Yes? Is that understandable? Okay, so now let me ask you another question. So, assume that, I would say like this. So let logarithm of 2 be called A? Of course, you can put it in the calculator, it's approximately 0.3, but we don't care. Whatever this is, I call it A. And whatever log of 3 is, I call it B. Okay? I'm not very interested in in the values of logarithm 2. If you want to, you can put it in your calculator, you get an approximate value for A. Then what I'm asking you, determine logarithm of 6 to base 5 in terms of A and B. Yes? So my question is that, give me a formula for this so that when I give you log 2 and log 3, you can put it in that formula and immediately calculate this. So I want you to understand this word, this phrase, in terms of A and B. It means that write this equal to something related to A and B, where A and B are these numbers. Okay? And whenever you have your answer, you can just tell it to me. Is the question clear? Yes? So what I'm saying is that assume that I know the number for this and I know the number for that. So I give you the calculator, you put this number in your calculator, put this number in the calculator, then I take the calculator from you, and then I ask you, based on the information you got, calculate this one, now without calculator. This is another way of phrasing it, yes? That's the meaning of this question. Do you have your answer?
No, but I was going to ask, could you please repeat what you meant by in terms of A and B?
In terms of A and B, this is a very common phrase. When I say write something in terms of something else, it means that write this thing equal to something. In that something, only A and B are involved. Yes? Or some numbers are involved. A relation, so you write a relation that relates this number to these numbers. That exactly means that. I give the calculator to you, you use the calculator to calculate these two, and then I take the calculator from you and I ask you to calculate this.
Okay.
Yeah, that's another way of seeing the problem.
Thank you.
No? Do you have your answer?
2 equals B.
No.
Sure.
Rasmus?
A plus b divided by log of 5.
No, log of 5 is not acceptable, but your answer is correct.
Or
Yes, you are right. But log of 5 is not given.
well,
Log of 2 and log of 3 are
yeah,
given.
but I used a and b and like
No, when I say write in terms, it means that,
yeah, in terms of a and b, and an expression which uses a and b.
yes,
At least like what
but what I'm asking you, just get rid of log of 5 as well.
Okay, sure.
Because what I told you is exactly the same thing. I give your calculator to calculate log of 2 and log of 3 and I get it back from you.
Okay, I guess that makes sense.
But you are right, the answer is correct. What is your answer?
I would say the same thing.
Okay,
Log
but
of 2 plus log of 3 divided by log of 5. Yeah, log of 5.
that's correct, but it's not acceptable for this time.
What?
I wanted to get rid of log of 5, as I told you. I give you the calculator, you use the calculator for log of 2 and log of 3, and then I get it back from you.
So you want us to write it in terms of a and b
Yeah,
without
exactly.
any logs?
Yeah, exactly.
Okay.
Two or 3 equals B.
No, A plus B is correct. What Rasmus said is completely correct, but he used log of 5 as well.
Yeah, log of 5. 2, 3.
What is the base here? It is not written, so the base there is 10. But here the base is 5. So how do you think about the problem?
Oh yeah.
Because you are dealing with something in the base 5, the information provided for you is in base 10. So it should remind you of one very nice formula. the base change formula, yes? Because what you get as the information is base 10, but what you need is base 5. Yes? So what is your suggestion then? The question mark is equal to what? This I expect you to know. So this is because you have a list of formulas. Even though formulas in front of you, you need to know which one I have to use. You cannot use all the combinations, yes? So you have to have a very nice strategy to tackle the problem. So, you see, this is the way that I think. The information given to me is involves logarithms in the base 10, but I need to answer a question regarding a logarithm in base 5. So immediately when I think in that way, it will remind me of one single formula, and that is the base change formula. So how can I do that? Which base is better for me to go?
10.
Because the information is in base 10, so I will go in base 10, and I hope that immediately you realize that you can write something like this. So this is the question mark. Is that understandable? But then log of 6 immediately becomes clear. What is that? It is 2 times 3. Why this is useful to think in this way? Because it relates itself to these two numbers. But then, what can I write for 5? 5 is not acceptable. I can write 10 divided by 2. Yes? And then what happens for the numerator? As you mentioned, Rasmus, it's correct. It becomes log of 2 plus log of 3. But then I have the log of division. So it becomes log of 10 minus log of 2. But log of 10 is not an obstacle because log of 10 is 1. Yes? So then it becomes log of 2 plus log of 3 divided by 1 minus log of 2. And now everything is okay. This is a plus b divided by 1 minus a. Yes? So it means that if you have your calculator and you know a and b, you can put them here back and calculate this question. Yes? Okay, so let me ask you another question. So, I would say let A and B be positive numbers such that A squared plus B squared is 7 times AB. What these numbers are is not our problem, yes? We have A and B positive numbers that satisfy this condition. Okay, we want to show that, prove that this is the thing that we are supposed to prove. Prove that logarithm of A plus B divided by 3 is equal to 1/2 is equal to logarithm of A plus logarithm of B divided by 2. So we have two positive numbers that they satisfy this relation. We want to show that if they satisfy this relation, they will also satisfy this relation. Yes? I just want to see how you think about the problem. And by the way, these problems are quite hard problems. Mathematics is to actually improve your problem-solving skills. It doesn't matter in the future, if you want to get a good job, you should be a good problem solver in your field. It doesn't matter if it's directly related to mathematics or not, but learning mathematics will improve your critical thinking and the way that you need to think to be able to solve a new problem. So don't underestimate this. If you want to get a good job in the future, you have to improve your problem solving skills, no matter in which field you're supposed to work. Okay, how are you thinking? Yes, Rasmus, do you have any idea?
Yeah, or like we can use the quadratic formula to like do some things with our initial equation that we have been given, and lend 2ab from 7ab and move it over to the other side, so that we have a squared minus 2ab plus b squared. And then use the correct formula to change that to a plus b in brackets squared is equal to 5ab.
So your grand picture is correct, but technically it is wrong.
Okay.
So it means that what you describe is very good, but I will not borrow 2ab, because if I borrow 2ab, what's the problem with borrowing 2ab? Can you see it yourself? So you said that I borrow 2ab from the other side and move it to the left-hand side. What happens? If I were you, I would not continue, even though your grand picture is correct. Technically, I will not follow this. Why is that? Why I will not follow that? Can you just tell me to?
Right.
If I move 2ab from that side to the other side, then the quadratic rule that I get is a squared plus b squared minus 2ab. And then if you want to write it as complete square, you will write it as a minus b squared.
Oh.
Technically, this is not good. That's what I'm saying. But what I see, a plus b appears somewhere, not a minus b. So even though your grand picture was completely right, technically I will not pursue that, because even if I succeed to do something, I definitely end up with a minus b, which is not demanded. Yes? Okay? Yes? Can you fix it yourself now?
Yeah, I think so.
What do you do?
We instead of lending, we just add
We
to it.
add to it. And that's the point. Yes?
Yeah.
So
I have my solution.
yeah, okay, good. So if you add 2ab, so I mean, I don't know, if you are interested in improving your mathematics, I cannot go into your brain to tell you how to work, but you need to teach that yourself. You need to ask yourself, why I was not able to see this point. Next time you will be able to see it if you are that interested. So what Rasmus is actually presenting is this. So he is saying that a squared plus b squared is given to me to be 7ab. This is given. So then it means that he somehow sees. How he sees, you need to do practice on it, okay? So why, of course, you can add whatever you like to the left-hand side, as far as you also add the same thing to the right-hand side. But this is the only one that works for this purpose. Okay? And then by practicing, you will learn. Why? Because you immediately see this pattern. If you already know the pattern, of course. And then 2ab plus, it becomes 9ab. Now, I think why this is reasonable, because what I want to prove is something related to a plus b. I hope that some of you don't make this mistake if I take square roots of, because still some of you might think that, okay, I need a plus b, why don't you take square roots? If I take square roots, I will get this one, but some of you might think this is equal to a plus b. No, that's wrong. Yes, so that's not possible, even though this is true, but I cannot go from here to here. I am stuck here, okay? So, this is the only thing that I got here. But now, anyone else, can you tell me how to continue now? So, the Rasmus told us what to do. No, you have your solution. So, someone else. Do you now, so just look. What do you think I will do here? It's very reasonable now. The next step should be very reasonable for you to do what? Just look at what we are supposed to prove and compare it with what we have right now in our hand. Yes?
Divide by 9.
Yes, how did you? So this is easy, you see? It's coming natural because he's seeing that the 3 is below here. Okay? So she decides to divide by 9. Because if you have 9 here, you have a power of 2 here, 9 is also 3 to power 2, so you will have that construct that you need. At least somehow, yes? So that is, you see, it is natural. I mean, by training, you really make it possible to understand. Okay, now if you understand what is going on, what will be the next step that I will do? Because this is not exactly what I need, it's very close to what I need. I would write it in a way that what I need emerges, yes? So what should I write instead of this? Can you tell me what should I write instead of this? A plus B divided by 3 totally to power 2 is equal to AB. At this point you should be very happy, yes, because you were able to get this expression that you need somehow. But unfortunately, this is not related to logarithms at all. But what would be the next step? Someone else? What would be the next step, do you think? I don't have logarithm. I want to have logarithm. What's the next step?
Use logarithm.
What?
Use logarithm.
How? Because if this number is equal to this number, then the logarithm of this number.
So you would do logarithm of AB base A plus B divided by 2 is 2.
Yes, so I would say to myself that you tell me that these two numbers are equal. You didn't tell me this. You told me this number is equal to this number. Based on my math knowledge, I was able to conclude that this number is also equal to this number. And then when two numbers are equal, definitely the logarithm of this number is also equal to the logarithm of that number. Yes? If two numbers are equal, the logarithms are also equal. Yes? Is that understandable? Yes or no?
Yes.
If I give you the same numbers, the logarithms are also the same. But now I think everything becomes ready. Yes? What can I do with these two? Compare. What extra things I have? I have an extra 2 here. I don't need it. So what should I do? I should get rid of that 2. There's only one way to get rid of this 2 to move it back. So this becomes 2 log of A plus B divided by 3 left. But then, look, I have logarithm of AB, but the person is asking about logarithm of A plus logarithm of B. Is there any way to do that? Yes, there is one simple rule for that. So this becomes logarithm of A plus logarithm of B. It's more or less finished. But you see there is no 2 here. So I have to get rid of 2 by dividing by 2. So this becomes logarithm of A plus B over 3. And then I have to divide this one by 2 as well. Yes? Is that understandable? So if you look at the problems logically, it's not that hard. But I see a problem here. I myself enjoy solving it. So let me just tell you how can you solve it. It's elegant, yes? A is positive. First of all, any questions here? Understandable? So the point is this. The point is that somehow you learn how to be independent of teachers. So I don't know, even if I solve hundreds of problems on the board, that they are useless until you teach yourself how to think. And these are just excuses to do that. So let me just, I really enjoy this problem. I saw it right now. A is a positive number. I want you to simplify this expression as much as possible. Every interpretation and everything is on you. So don't tell me that I was confused or whatever. Is that a product? So it's not a good question to say what is the sign between these two logarithms? There is no sign, yes? How do you interpret this? Can you tell me? Yes?
The log of A?
Yes, so it means that you calculate log of A, it becomes a number, and then from this number you take another log. So, and then everything that you see here is the exponent of A. Might be I have written it a little bit sloppy. So this is the way that you have to think. A is in the, let me make it bigger. So A is in the base. And then this expression is at the exponent. It's simple, you see, it's not that complicated. But I want you to try to simplify this as much as possible, okay? A is also given to be positive.
A could be 1.
No, you are right, I am careless.
Okay.
A cannot be 1. Of course, I am not, so these conditions is not written in the problem, but A cannot be 1 for obvious reasons, because log of 1 is 0 and then it cannot appear in the fraction. So log is not 0. Yes?
Is the answer log of A?
Yes. So it's an elegant problem, but can you describe why?
I thought of the log of A on the top as like box,
Exactly.
and then I used
exactly. Thank you very much. Yes, that's the point. Yes, that's the point. But I don't know. Can you describe how did you come to that conclusion to take log of A as a box?
because log of log A is just the number log A, like the log of that number.
Yes.
So what I thought was, instead of having it be log A, because it can be confusing, so I just
Yeah.
thought of it as box instead.
Yeah, exactly. So what he's
Because it's
just
easier.
describing is exactly what I want you to learn. So he's putting this. This is distracting him. He's just putting it in name. Whatever is that, who cares? Yes? And then you have another log A. But I don't know. This combination, that is what you need to do in mathematics. You need to train your eyes to catch the patterns. Is this a nice pattern for you? Have you seen this pattern before? You have a log of something divided by log of something else. So what can you write?
Since it's the base change rule, you can write log of box with base A.
Exactly. Is that understandable? Yes, this becomes log of box in base A. I told you that. Usually harder problems go in the other direction. If I have written this and I ask you to change it to base 10, I would say 90% of you were able to do it. But the point is that to be able to catch the other way around as well. So I have two logs divided by the same by each other, so I can write it as log of this one in this base. So what you see, you can write A, and then you can write log of the box in the base A. Yes? But then hopefully this pattern should be familiar to your eyes. If not, the chances of solving that is very low. Yes? Okay, so what is the answer to this?
Log of A. Log of A.
So this becomes the box. Yes? This one and that one are the same, so the answer becomes box. But what was box was log of A. So it's a nice problem. You see, it was simple, but you have to understand a lot of things. So this expression is just nothing except log of A itself. And that's also interesting. You have log of A, put it here, take another log, divide it by log of A, and when you raise it to power that, everything is gone, log of A is left. Yes? Is that clear? Okay, another interesting problem I see here, I see that how many of you can solve that, okay? It's simple, but no, I mean, these are hard problems compared to a standard Math 2C level problem. But you see they are not hard, and it depends how much you want to make progress. Okay, so let me assume that everything is defined. So I don't want to write the conditions to disturb myself. So assume that everything that I write is well defined. And I want you to see that. I say that x, let x be equal to log of ABC for acceptable values to the base d. And let y be log of what is that? Log of ACD in base B and let z be log of ABD in base C, and finally t be equal. I'm just this problem is intentionally making it hard. Yes, yeah, but it is not hard. BCD in base to the base A. So I don't know what are these numbers, but these numbers assume that they are all positive, not equal to 1, if for simplicity. X is this one, Y is this one. Let me just double check. ABC to the base D. The next one, ACD to the base B. ABD to the base C. And then BCD to the base A. Yes. I want you to answer this question for me. The question mark is equal to 1 over x plus 1 plus 1 over y plus 1 plus 1 over z plus 1 plus 1 over t plus 1. I want you to answer this question. Yes? Yes, Rasmus, do you have questions or you want
Yeah, I have a question. Is all those terms A, B, C, A, C, D, are those in brackets?
Yes, if you
Or
want.
do you have to write those brackets? Or I thought you had to do that.
Yes, I think you are right. So let me just do that, please. Okay. So that is a good problem because we don't have any numbers. Everything is a variable here. But then whatever they are, I want you to calculate the sum of those 4 fractions. Okay? Yes. I want to wait for you. Okay, so Rasmus, how did you think about the problem?
If we if you just focus on one of these
This is something you need to learn, yes? So when the problem becomes very complicated, you shouldn't get distracted to look at the whole problem. This is some skill that you need to acquire, and that's possible. It's different from IQ that might be people cannot increase that much. But this is a skill that you can acquire. The problem is complicated. I have 4 fractions. Why should I be bothered about 4 of them at the same time? Yes? So let us just concentrate on one piece. Of course, it is clear if I cannot. So you need to go back and forth. Sometimes focusing on one makes the problem harder. Sometimes focusing on one of them makes the problem easier. Yeah. You need to acquire these skills, okay, if you're interested. So for this problem at least, I would start just by looking at one single fraction to see what can I do. If I cannot do something with this one, then it's hopeless. Yes? So what I want to do, I would write 1 over x plus 1. Then when you have this wise decision, the next steps are more or less natural. The reason that I call it natural, I want another volunteer to tell me what do you think I will do now. Yes.
Instead of x, you write.
You see, it's natural. So more or less, it is now clear. So you replace x with that expression. Okay. The next step might not be that much natural, but I need to think, what can I do? So, for example, I don't know how you think, but the way that I was thinking, I was actually asking my God, what would happen if 1 was not there? Yes? Because if 1 was not there, what could I do at least? Assume that 1 was not there. Can you write something for it? Do you remember?
A, B, C.
So yesterday I told you log of A in base B can be written as 1 over log of B in base A. So if you have forgotten that one, there is no hope that you can solve this problem. Yes? Now I would say that if 1 was not there, I could write it the other way around. At least I could do something. But now, unfortunately, this 1 prevents me to do that. But because I am human, probably I can adapt myself. Do you know how can I get rid of this 1 there?
Log D base D.
Log D base D. Why didn't you choose log B base B? That's also correct.
B base D.
Because you told me to write 1 to be log D.
Oh, yeah.
D. That's correct.
To-
Why didn't you choose this one even though this one is also correct?
Because I can combine it with.
Because I need a D here, not a B.
Yes.
So then what I do, I will continue. So this becomes log of ABC base D and plus log of D base D. But now, what was the goal of Oscar to tell me this? Anyone else? Can you tell me why this is useful? Yes?
Because you can put them together. So
You
it's
can combine them, yes? So this becomes the log, 1 over log of A, B, C, D to the base D. But now, what I needed is now here is established, yes? I have 1 over this, I don't have this bothering 1 there. So what can I write now? I can flip, yes? So this becomes log of D, but here A, B, C, D. So what I did is actually quite good. Now I want to ask you again, okay? So, so what I did, I was able 1 over x plus 1. I realized that this can be written as log of D. The base is A, B, C, D. Yes or no? But now, do you see what is happening?
Yes.
What is happening?
You can do the same,
You can do the same thing
but you don't.
with the next one. But don't do the calculation, just try to guess. 1 over y plus 1. So you need to convince yourself. I recommend you to do this once more at least for the next fraction. But can you guess what do you get at the end?
Log B.
You get a log at the end. What do you will have here? It will be A, B, C, D again.
And the B.
Yes, but what happens here is B. Yes? And then the next one, can you guess what will happen if you do the same thing? You get another log with A, B, C, D here, and what do you get here? C. And then finally, you will get log of A, B, C, D. What do you get here? Is A. Yes? And now I am supposed to add these. But adding these are extremely simple. Why? Because now I have the same base for all logs. Yes? So if I add them, the question mark is this plus that plus that plus that. But what can I write? I can write the same log, but instead of adding the logs, I can multiply these numbers. D, B, C, A. But D, B, C, A is the same as A, B, C, D. So that is the log of this number in its own base. So that's the answer is 1. Yes?
Yeah.
So I think that was a good problem, yes? So so this is something you need, if you want to be a good problem solver, you have to remember this trick. So that was a hard problem if you wanted to look at the same the problem at the same time, but you broke it into different pieces and then use the symmetry. Even I'm sure that after doing the first one, Ali actually told me what will happen for the next one. You even could guess. So when you can solve this problem, you are relieved that you know what to do, and then you continue. Yes? So these are the things that if you are interested, you can improve. Okay, I will stop here, and I will update the Google Classroom which parts you can solve and read. But I think the problems in the book should be simple for you now. But I will write a problem here for you next time. If you want, you can practice. I think it's a little bit challenging. I don't know. I want you to calculate this without calculator, of course. That is up to you. If you are interested in hard problems, think about it. Otherwise, just leave it. And by the way, the exams will not be at this level, okay? So I want you to calculate the value of this without calculator. Logarithm of 18 base 12, that might be extremely challenging, times logarithm of, let me just not confuse, 54 base 24 plus 5 times logarithm of the same number minus logarithm of the same number here. Let me double check everything. No, yes, that's correct. 18 base 12 times 54 base 24 plus 5 times the difference, 18, 12. So that is why this is challenging, because we do not have any power relations with the bases. So I would consider this challenging without calculator. So this is the product between this log and that log. And then 5 times the difference. I want you to answer the question mark. But do it if you have time. This is for only the interested students. Okay, thank you.